This is not me. I am not Daniel Schiffman, and this is not the Coding Train YouTube channel. But chances are high that you will have seen some of his videos in the past. They are super fun to watch, and he is an absolutely amazing teacher. He uses a programming environment called Processing. It is very beginner friendly and has fantastic animation capabilities. In fact, if you go to p5js.org, you can readily use it from within your browser without having to install anything onto your computer. But the processing syntax does have its drawbacks. It uses a lot of curly braces and it has many semicolons. If only there was a way to combine the best of both worlds: Python's clear-cut syntax and processing's animation toolbox. And if possible, do the whole thing from within your browser. Well, in this video, we'll do just that. And it all starts by going to this homepage that I recently discovered called Trinket.io. This is the homepage that you'll see the first time that you go there. It's going to look like this, except that you're not logged in. So right now you can see that it says Coding Cassowary up here. This is because I'm already logged into this. And there will probably be a login screen when you first go there. And you can log in there or create a user account in the first place with your email address or your Facebook or Google login. But once you have logged in, you can go up here and then you get started with your coding. And you can just go to Google at all times and just type Trinket Python Processing and then click on the first link, and it should open up everything the way you need it. And then you will be able to code processing in the Python mode using Trinket. Now let's have a look at what we will be building today. So this is the project as what it's going to look like in the very end. And what I would always advise you to do with all of your sketches is to go up here and you click on full screen. Now this is not exactly the same as if you were to hit, say, F11 in your browser or whatever other keyboard shortcut it is for you to get into full screen mode with your browser. But if you do it this way, then this whole thing is now really going to feel like a proper code editor. So if I hit the top of the screen here, the browser bar is not popping back in, and it really feels like an actual coding editor, except everything is happening in the browser. Now anyway, here you can see some code. Don't worry, we'll start from scratch as always. And all that I'm going to do right now is I'm going to hit run. And now you can see over here, this is the product that we will be working towards. We have a bunch of little bouncing particles that are bouncing back and forth, up and down all the time. And you can see that they are being dragged down by some force like gravity, and eventually they will all be located at the bottom of the screen. But there is more to this, so I'm going to stop here, run this again, and now I'm going to repeatedly press the mouse, and then something cool will happen. So watch this. All of the balls are being pushed over because there's another force, something like wind, coming in from the left hand side of the screen, which is forcing these balls, these particles, over to the right. So I'm just applying more and more wind to this, and I'm really trying to push them all over. But of course, once they bounce back, they get energy or like some force pushing them to the left, and this just keeps on going until they're all at the bottom. And now down here, you can see why this animation is anything but perfect. First, there is no drag or friction to this. So these particles, once they are at the very bottom, they will just continue to float left and right if there is some force acting on them, and they will never be slowed down. And the second thing, that's, well, these particles, they can intersect with one another. They can just go through one another. So there is no object collision happening right here. And there's plenty of ways in which you could make this more realistic, but that's not the point of this video tutorial. The point of this video tutorial is to have some kind of little project that we can work on, and well, we want to get to know about processing. And without further ado, let's get started. All right, I am now in a new sketch. So in processing, projects or files are sometimes just referred to as sketches. So it's a sketch with some code here and then some output visualization, some animation or something like that over here. Now the first thing that we want to do whenever we are working in the processing environment is to just import processing. So we'll say from processing, import everything. And while we are at it, I'm going to import from the random module the uniform distribution. Now to set everything up, so the processing sketch, there is not a lot of boilerplate code necessary to do that. After all, that's kind of the point of the processing environment. All that we are going to need is a setup function. So that's a predefined function here in processing. You always have to use it. It's called setup. And then we have to have the run command down here. And in setup, well, actually, let's run it like this. I'm going to run this, and this runs, but you can already see some output. Even though it's just almost nothing, we can see that something happened. We just produced this little square over here. Now we can adjust the size of this square, which is going to be the canvas onto which we're drawing. So I'm going to use a function called size, and in this size function I will specify two integer values. I'm going to set this to 500 and 500, and we get this. Now this canvas is a lot larger. I'm pretty sure that you can already guess what these two values are. Let's change the first one to 200, and now you can see that the canvas is much more narrow. So obviously these two values are the width and the height of the canvas. Now we can draw our canvas like this, but can we also change its background color? Sure we can. We do that using the background color. So let's just use background here and type in 100 and see what we get. I run this, and you can now see that the background is a lot darker. If I was to set this to 0 instead of 100, it would be pitch black. If I go to 255, which happens to be the highest value possible, we get a super white color. You know what? Let's make this a square again, 400 by 400. 400. And you might be asking yourselves, well, is it only grayscale colors that we can use here? No, it is not. So right now we only specified one value, and if we do it like this, then processing will infer from that that you will want to have a grayscale color. But if you specify three values, then processing in Python mode is going to interpret that as an RGB triple. So we'll have a red value, a green value, and a blue value. So let's just add two zeros here. And if we do it like this, then we get a super bright red, because the red value is at its maximum and green and blue are at their minimum of 0. So if we settle somewhere in the middle, say, I don't know, pick 200 for red and 100 for green and 50 for blue, just like that, we can then mix any color that we want. But for our purposes, I think a rather neutral background color is going to do just fine. So I pick 220, and we have this light grayish background here. Now the next function that we always have to have in processing is called the draw function. This is the loop that is constantly happening at every frame of the animation. So this is very similar to Pygame. If you happen to know Pygame, you will really spot the similarities here right on. So setup is everything that happens at the beginning of executing our code. It's only happening once. And draw is then a continuous loop. So any sort of animation will have to happen within the draw function, because this is only happening once. No objects are moving up here, but everything is moving down there. So let's have a little ellipse down here, which we can create using the ellipse function. With the ellipse function, we have to specify an x and a y. I'm going to set these to 100 and 100. And now we have to specify the width and the height of our ellipse. I'm going to set both of these to 50, which should now produce a square. So let's stop this and run this again. And there we go. We just generated this little square, this little circle up here. Did I just say square? No, it has to be circle, of course. Now, if I was to change this to say 100, it's no longer a circle, but it's just an ellipse, right? So let's go back to 50 and 50 here, and let's try to change the color of this. Now, background changes the color of the background of the canvas. But there's another function called fill, which changes the color that we are using to fill our objects. So I'm going to use fill 50 here. Let's see what that does. Well, boom, we now have a pretty dark ellipse here. And again, if I use three values here, let's say I was to use 100, 200, and 50, we now have a green ellipse, right? So pretty simple stuff. It's not too hard to understand. So let's just try to find a nice color here. This is kind of too green for my taste. This is orange. I guess that's fine. What happens if we add some more blue to this? Not a whole lot. Let's add more. Okay, this is now kind of brownish. It doesn't really matter. I don't want to be playing around with these values for too long. So what I'm going to do is I'm just going to say that I'm going to set these to 255, 100, and 255. And that should produce a rather pinkish color here, actually. And if I add another value to this, 155, well, in that case, it will be somewhat transparent. So let's add another ellipse into the vicinity of the first one. So I'm just going to move this over by 20 pixels. And now you can sort of see both of them. So they are really overlapping one another. And this is because of this fill parameter here, this fourth parameter here. If I remove that or initialize it to 0, then one is completely on top of the other and we cannot see through it. But if we add some transparency to this, then you can see both of them at the same time. So let's just increase this to 255. And now it's perfectly solid. And if we go down to 0, well, then there's no color in there at all. If we go to 1, then it's really faint, but it's there. But you can actually see how it increases over time, right? So let's start this sketch again. Right now, nothing is there, and now the color is coming in one step at a time. And this is because, well, as I said, draw is a continuous loop. It's happening all the time with every frame of the animation. And now we're drawing it once, twice, 3 times, and now it's really just starting to fill in the colors here. And yeah, I think this already illustrates how this continuous loop works, but to be more clear about this, let's just simulate an X here, which we'll draw from the uniform distribution up here, uniform, and then we'll say pick a value between 0 and the width. And that is how you can make use of the predefined width up here. You can just type width and then processing is going to know what you are referring to. So you don't have to hard code that 400 up here again. Let's just, well, randomly assign these X values here. But you know what? Let's make this X1 and X2. So we have 2 ellipses. Each have their own X value. And let's run this. And now you can see, whoa, this is happening all over the place. We're drawing so many. And if you don't want this to happen, if we want them to, like, you know, fly around instead of seeing all of them, all of the previous versions of the ellipse, well, there's a nice little trick. We just draw the background again at every frame of the animation. And now, if we run this now we have these 2 ellipses that are flying over the screen, except that it's going really, really, really fast. And we can change this by setting the frame rate to maybe only 10 frames per second. So we can do that using the frame rate function. And now you see that this is not happening super quickly. And actually, let's bring this back into 200, the transparency parameter. And now we have 2 ellipses that are flying over the screen, and you do not see all of the previous versions of these 2 ellipses. Anyway, these were some of the basics of how to use or how to set up processing in Python mode. Let's get started with our actual project here, which is our little physics animation. And for that purpose, I'm going to remove one of the 2 ellipses. We don't have to have both of them. Let's go back here. And what's the problem now? Okay, X is not defined. Yeah, sure. Run this again. Okay, so we now have our first particle here on the screen. How do we make it move? Well, what we'll do is we'll create a class in which we'll store the location of this of this particle, and we'll also store its movement, right? So we'll store its velocity and its acceleration. So you know that physicists, when they think about particles, they think about their positions and their velocities and their accelerations. And together, using these 3 things, we can then describe how they move and behave throughout time. So let's create this little class, which I'm just going to call particle. And now we have to have a constructor function. So def init. I'm assuming that you already know how classes work in Python. This is not a complete Python beginner's tutorial. If you've never seen a class, well, this constructor function here with this very weird name underscore underscore init underscore underscore, this is used to actually create an instance of that class, and you always have to have that self in there. And then we'll say, well, we'll make their positions completely random, so we don't have to specify anything here just yet. So we'll say self.x is equal to, well, you've seen this before, a random value between, and now I can't use width because the width is only being defined down here. So what I'm going to do is I'm just going to have to hard code it one more time. So 0, 400, and the same thing for y. And this should now be a random position. And let's create a bunch of these particles. So what we'll do is we'll say particles are equal to a nice little list comprehension. So we'll say particle, but uppercase and with 2 parentheses. So we are now referring to this class up here, and we are now using that 20 times. So for I in range 20, we are now generating all of these little particles. And let's use a print statement down here, print particles, and run this. And now, down here, you notice that we have a little console popping up down here, and it has printed a list. You can see this by these 2 square brackets, and you see that within this list we have 20 little particle objects. So this apparently worked. Nice. In addition to just creating these particles, we now have to have a function within our particle class to draw them to the screen. And I'm just going to call that function show. And we have to have self in there again because it's a function that is applied to each particle themselves. Now, in our show function, what we'll do is we'll just pick up the code that we had before. So I'm just going to take this code and move it back up here. And we have our ellipse. This is the color. And now we have to set this to its X location, and we'll have to set this to Y. And you know what? I'm going to make this a little bit smaller. And actually, let's define another variable up here, the diameter of the ellipse, which I'm just going to set to 20. And now we can just say self.diameter and self.diameter. And in our draw, we'll now say for P in particles, P.show. And I think that should be it. Let's remove the frame rate. We don't need that. We remove the print statement. And now this is all we should need. Let's run this. And there we go. We have just generated 20 little particles onto our screen. And if I run this again, they are now in a different location because, well, as I said, this is happening randomly. Now anyway, the next step for us would be to have them move. And what we'll do is we'll create a new function, which I'm just going to call, it update. So this is a function which will update the position and later on also the velocity and acceleration of our particles. So update of self. How do we do that? Well, the position of x, self.x, will now be equal to, and this will now be equal to the previous position plus the velocity in either direction. So we'll add to that the velocity in the x direction. We haven't defined that, so we've got to do that up here. So we'll say self.vx, and we'll set this to 0 at first, but later on it will be a different value. And we'll have a velocity in the y direction. Now, same thing here. And this is now update. And to make use of our update function, I'm going to incorporate that down here, p.update. Now it's updating with every frame of the animation. Of course, we don't see anything yet because the velocity is equal to 0. So let's add maybe just 1. So we are moving one step to the right with every frame of the animation. I think I did not explain this before, but the origin in our sketches is in the top left corner. So this is very similar to Pygame. So you have 0, 0 up here, and then you step to the right and down if you increase the x or the y values. So let's see if that works. And there we go. We can see that the particles, because of our velocity of +1 to the right, they are now moving to the right. If we add movement downwards, you can now see we have them moving diagonally. One step to the right, one step down, happening at the same time. That's a diagonal step in the top right, top down direction. Top down, that doesn't make any sense. In the bottom right direction. Alrighty, so we have movement in here. But to make this behave like an actual physics thing, we'll now add acceleration as well. So I'm just going to call this ax and self.ay, and we'll initialize that to 0. Now in our update function, we'll now not only update the position x and y, but we'll also update the velocity vx and vy. So we'll say self.vx plus equals self.ax and self.vy plus equals self.ay. And then lastly, we'll reset ax to 0 and we'll reset ay to 0. Now the reason for that is we don't want ax and ay to just compound with every frame of the animation. Because in addition to that, right now if I run this, nothing's happening. Everything is initialized to 0. We have to have another function which will be a function to apply a specific force onto our particle. So I'm just going to call this apply force, another function of self. And now, well, we need two additional parameters here, which is, well, the force that we are working with. And this is a force in the x direction and a force in the y direction. And now what's happening is, well, what we are saying is we are increasing self.ax by the force in the x direction and self.ay by the force in the y direction. And now we got to make use of our force down here. So we'll say p dot apply a force. And let's just apply a force to the right. So 0, that is, oh no, this has got to be 1, and this is 0, because this is fx, left or right. If you use +1, then we are moving to the right. If you use -1, we are moving to the left. We could also use values different from 1, but I'm just going to use 1. And then we have our force in the vertical dimension, but I'm going to leave that at 0 for now. Let's see whether that works. I'm running this, and they're moving to the right. So this is really working. We now have a strong wind coming in from the left and pushing everything to the right. Let's just quickly see if we could reverse that. Not reverse it, but have it work in the vertical dimension as well. You just saw them falling down. So this is working just as intended. So what I'm going to do is I'm going to call this gravity, set this to 1, and now I'm going to apply gravity, or actually let's make it 0.1. Now they're moving more slowly. This is making a lot more sense. So this is, I think, working quite nicely. There's just one problem. I mean, these particles, they will now fall down forever. They'll fall down indefinitely, and their y position is going to decrease further and further and further, and, well, there's nothing to look at anymore. So what we got to have in here for this project to be a little bit more interesting, we have to have some ability for these particles to bounce off the left wall here and the right wall here and the ground. So, I mean, they don't have to bounce off right there because they will never ever get up here to the ceiling, to the sky. The sky is the limit. But down here we want them to be bouncing back of these walls here, so to speak. So, how do we do that? Well, we add another function to our particle class. And I'm just going to call that bounce self. And now, well, with every step that these particles take, we must always ask ourselves, are we moving too far to the right, too far to the left, or too far to the bottom? Let's start with too far to the bottom. So if self.y, that is the y position of our particle, and positions here always refer to the center point of our particles. So if self.y is greater or equal to the height of our canvas, so the height of our canvas, even though it's called height, really is sort of the depth, because the origin is up here at 0, 0. So this is now ground level, that is height. So if we are greater or equal to that minus half of our diameter, then the bottom part, the lowest point of our particle, the circumference of our particle, so to speak, will have hit rock bottom down here. So if that is the case, then we have to start to go back. Now, depending on how we choose our gravity value, which is really just then how far we are stepping by, we may have exceeded this bottom value down here before we have been right at there. So we might be just slightly above it, and then in the next frame of the animation we might be slightly below that level. And this is why I'm using greater or equal to and not equal to, because if it is equal to and we don't land exactly on it, if we step over it right away, then this condition wouldn't really work. So this is why we have greater or equal to here. Now, if that is the case, what we'll do is we'll reset y to this value. So we are moving it back up, and this will then make sure that even though we might have already overstepped, we're now stepping back. And we've got to have height here as well. So we'll reset that, and then we'll also change the velocity of our y direction, and we'll just multiply that with -1, which means if we were going down, we're now going back up. Let's see if that works. I'm not going to run this. And unfortunately, it does not. Well, obviously it doesn't, because I haven't used our function. So let's run this. And now you can see that these particles, they bounce back up. Now, how cool is that? This is now actually working, and eventually they should start to settle down, because gravity, let's increase this, is going to make them bounce up a little bit less every time that they bounce. So these amplitudes should get smaller and smaller. And I think, yep, this is exactly what we see up here. eventually now we have 1, 2, 3, 4, 5 particles at rest. Now this one, and now eventually they will all drop down, come to a resting point here, and then it's basically over. Awesome. Lastly, let's add this idea of having wind coming in from the left-hand side of the screen. And we don't want this wind thing to be happening constantly, but only when we press the mouse. Now, how can we achieve that? There's another special function in processing which does just that. And this function is called mouse pressed. So mouse pressed, and then we'll say, instead of having gravity, we'll now have wind equal to 1, and then we'll say for every particle in our set of particles, we'll apply wind, but wind works in the horizontal dimension, so it's wind 0 instead of 0 gravity. Let's see if that works. So I'm now starting to push these particles, but I'm now pushing them outside of our canvas. But the pushing part works. We now have wind coming in from the left and pushing these things over. So we gotta make some adjustments to our bounce function to make sure that they don't go out of bounds, so they bounce back from the bounds of the canvas, okay? So if self.x is greater or equal to the width minus self.diameter half, so this is pretty much the same thing that you saw up here, just with the horizontal dimension instead of the vertical. Well, in that case, we'll reset x equal to that value, and then we'll change the horizontal velocity, so vx times equal minus 1. Let's see if that works. I'm running this. I get an error, and what's the issue here? Okay, this is just a little indentation error. Let's run this again. Apply the wind, and there you go. They no longer go off bounds. Over here they bounce back, and now they can still go out of bounds on the other side though. So let's adjust that as well. Else if self.x is less or equal to 0. So 0 is really the left-hand side here. And then, well, not 0, we have to say 0 and then plus self.d half again. If we are less than that, so we can ignore this as well. It doesn't really do anything. We are resetting x to just, I'm going to be doing this the same way. So 0 plus self.d half, and then we're reversing this direction here. We're making this times equal minus 1 again. Well, let's see if that works, because if that works, we are basically done with the project, and it does. So they're now bouncing off the left and the right hand side margins here, and everything is, I think, working as it should. And yeah, we might add some comments here. So this is our particle class, and then, I mean, you get the idea. This is our constructor function, update function, and so on. I think we don't have to do that for everything here. Create particles in a list, and this is setting up the canvas. I'm just going to call it canvas. You could also call it the screen. In Pygame, people typically call it a screen, and this is now the I'm just going to call it the animation loop. This is mouse interaction. And then lastly, this is the execution, really. Anyway, this project is now basically done. We have a working physics animation here. And all of that happened in really just, I mean, we now added some comments to this, but it's really 60 lines of code maybe. And I think that's pretty amazing. So yeah, I had a lot of fun doing this with you guys. In the future, I will post more videos that use the processing mode of Python. You can make all of this run locally on your computer as well, but there is a somewhat tedious installation process involved because you have to also have Java working on your computer, and it depends on which operating system you're using. And I think it's pretty annoying. So this Trinket solution here, which is entirely web-based and works just within your browser, really is the way to go here, I think, and it makes things incredibly simple. And if you happen to have watched videos by Daniel Schiffman on the coding train, you will have noticed that in some of his videos, he also just uses the P5.js web editor, which is the web editor for the real thing, for the real processing as it was written in Java and JavaScript. But here, I mean, I think this is really the same thing. It works for Python, and it's pretty nice, and we can really combine the beauty of processing in terms of producing nice animations in no time with the super clean syntax of Python. And yes, I hope you like this, and I'll make more videos about this. I'll copy other people's ideas. So this was stolen from the coding train. Another shout out to this channel here at this point. Definitely check it out if you have not done so in the past. If you have, and if there is some project that you were really amazed by and you would like to see it on the Coding Cassowary, let me know in the comments. I will then try to recreate it here in Python as well. Other than that, another great source for inspiration is Open Processing. You can go to that homepage and you will find a gallery of cool sketches that people made. Well, this will be JavaScript code, so there will be a lot of curly braces, there will be a lot of semicolons, but other than that, it's pretty much the same thing. And if you spend a little time of this, you can really get through this and translate this into Python. Now, if it's not working for you, just let me know. If there's something you really want to see on this channel, I will make a video about it. So just leave me a comment. And I think this video is now long enough. I'll hope to see you in another project. See you then.